welcome back. This is section 1.3 dimensional analysis, and we are going to talk about how to do converting of units. So the definition for dimensional analysis is a technique that's used to convert from one unit to another. In chemistry, a lot of times we're given information in a problem that contains one unit, and we have to convert it to a whole different unit. And you may learn in math that you can do this, and it's called proportions. But in math, sometimes we just have numbers in proportions without any units. So in science, we have units that we have with all of our numbers. So dimensional analysis is a technique that we can use to convert one unit to another unit. All right, so you have these 5 steps that I want you to memorize. You have to memorize these in order to get really good at dimensional analysis and to do this. And if you ever get stuck on a problem and you need my help, what I'm going to do is I'm just going to start reciting these questions to you. And so if you learn them and you can ask yourself these questions and answer them, you're not ever going to get stuck in a dimensional analysis problem more than likely. So go ahead and write these down. All right, so the way you start off a dimensional analysis problem is you take your given, what am I given, and you put that over 1. Now, sometimes there's a unit on the bottom that you already have. Like we were doing density, we have grams per milliliter. Okay, and you're going to see it like this. Well, that's a fraction. So if I have 3 grams per milliliter, I'm going to put 3 grams over milliliter like this. So I'm going to go ahead and put that over the milliliters. Now, you can understand that there's going to be a 1 there. But sometimes there are numbers there other than 1. So if it's already over something in a fraction form, just write it as that. But if it's not written in a fraction form, then go ahead and convert it to a fraction like this. Okay? So the first thing you want to do is you want to decide what unit is in your given that you want to get rid of. Then you're going to ask question number 2, where do I put that unit? Okay, and then question 3, what unit do I want to convert it to? Well, you're going to find a conversion factor that you've written down with that unit on the top. Number 4, cancel out the units, and I'm going to say this over and over. What's on top cancels what's on bottom. That means if you have an exact term on the top, whether it's a number or a unit, that will cancel out the exact same term or unit that's in the bottom. Okay, so look for units that you can cancel out. Then you're going to ask yourself the question, am I there yet? Do you have the unit in the top that you want for your answer? If the answer is yes, then do the math. If the answer is no, then you need to put in another conversion factor. So these are going to make more sense once we get into doing conversion factor examples in just a second here. But the first thing I want to talk to you about before I do that is converting between temperature scales. In the metric system, there's 2 temperature scales that we use, and it's the Celsius and Kelvin. And the conversion for this is really, really easy. What you want to do is say, for example, we have 23 degrees Celsius, and we want to convert that to Kelvin. All you do is add the number 273. Okay, and that will convert it to the Kelvin scale. So remember that number 273. So the way the number that we're going to get here is 296 Kelvin. Okay, so that's just converting it. And if you have a Kelvin temperature, you need to convert to Celsius. Of course, you're just going to subtract that 273. All right, so let's talk about the simple conversion problems. Very, very simple conversion problems. And these are 1 step. So we talked a couple of days ago about the metric system of converting between milliliters and liters, and we made a little cut and paste slider that we put in our notebook, and it was just showing you how many decimal places that you're going to move. So if we take 5.5 liters here, and we want to convert this over to milliliters. Okay, if we use that slider, that's going to tell you that you're going to have to move the decimal place 3 times. Okay, so if we have 5.5 liters, how many milliliters is that? So let's go ahead and add some zeros in here so we can know where the decimal is going to fall. So we need to move our decimal to the right. So if it starts here, 1, 2, 3 places to the right. So we're going to end up with 5,500 milliliters. Okay, so 5.5 liters is 5,500 milliliters. And that's just using the move the decimal technique. Now we can do this setting it up in a dimensional analysis problem. So if this moving the decimal thing gives you problems and you don't quite understand how to do that, you can always set this up in a dimensional analysis problem and get the exact same answer. Okay, so let's do that. So the first thing that we want to do is we want to take what we're given and put it over 1. And that's how we're going to start our dimensional analysis problems. So here's our given. Okay, using glues, we circle our given. We're going to list it out. Well, there's only one thing to do there, so there's really no listing out of that you need to do. Underline what you're looking for, how many milliliters, so you know where you're going with this. Okay, and then we're going to start writing out our equation. So the first step is take your given, okay, and put it over 1. All right, so it's not over 1 here. It's not over anything, so we're going to go ahead and just put it over 1. Now I'm going to take this line and I'm going to extend it out, and then I'm going to draw a vertical line here. That's the same thing, and you may see this in the book, or you may see it other places when dimensional analysis is being shown as multiply and then another fraction here, and then you're going to see multiply and another fraction here like this. What I'm doing is I'm just writing one line, and this vertical line here symbolizes us multiplying. That's just like, the density triangle that we were showing you. Density is mass over volume. Well, if we're looking for mass, cover it up, and it's density times volume. That little line tells us multiply. That's the same line here. It tells us to multiply. Okay, so let me get all this trash out of the way. All right, so we need to come up with our conversion factors. A conversion factor, and I'm going to abbreviate that as CF. And a conversion factor is anything that's equal to another thing. So say, for example, 1 inch is equal to, 1 foot is equal to how many inches? 12 inches. Okay, that's a conversion factor. Well, for this problem, we need a conversion factor that has milliliters and liters. Well, we know that 1,000 milliliters is equal to 1 liter. We learned that a couple of days ago with the metric system. So when you have an equivalency like this, you can write it as a fraction. So I'm going to put 1,000 milliliters over 1 liter. And the good thing about a conversion factor is it can be flipped. You can write it as 1 liter over 1,000 milliliters. Oops, too many zeros. Let me rewrite that part. Nope, I guess that was the right number of zeros. Okay, so either one of these is the conversion factor. Okay, now you want to write a conversion factor that contains both units that you have. If you have one, sometimes you're going to have to write 2 conversion factors. Okay, and we'll see that when we get to multiple step problems. All right, so we have what we're given over 1. Okay, so now the first question that you want to ask yourself is, what do I want to get rid of? What unit do you have there that you're trying to cancel out and get rid of? Well, the answer to that question is going to be your liters here. So where can I put this to force it to cancel? That's what you're setting this up to do, is to force units to cancel. Well, we know that if we have the same unit in the bottom part of this, what's on top cancels what's on bottom. So I'm going to put liters on the bottom because I'm going to force it to cancel out. Which brings us to question number 3. What unit do I want to convert it to? Well, you find a conversion factor that you've written out with that unit on top. So we have it right here. We want to convert to milliliters. Milliliters is in the top of that conversion factor. So I'm going to put milliliters here because I know I have a conversion factor that has that in the top. All right, so my next step, number 4, is cancel the units that I can cancel. Well, this liters can cancel with this liters. Usually I don't make a squiggly line. I just make a line like this. but sometimes those look like 4s when you're using liters. So I'll just squiggle out when I'm using liters. So I don't think that's a 4 and make some kind of math error. All right, so question number 5, am I there yet? What that means is you look at the unit that's in top here that you haven't canceled out and ask yourself, is that the unit that I want for my answer? Well, for this particular problem, it is, because we're wanting to know how many milliliters. All right, so the instruction is stop and do the math. Well, we have to put our numbers in first. So we just take the numbers from here and here and put them in. So it's 1,000 over 1. All right, so now we have numbers that we can do math with. So I didn't need my line to extend quite that far. So now I can do an equal sign. Now to do the math for dimensional analysis, you're multiplying. So you're just going to multiply the top straight across and the bottom straight across. So 5.50 times 1,000 is 5,500 milliliters. You want to pull over your unit that you have as well, over 1, because 1 times 1 is 1. But this is over 1, so it's 5,500 milliliters. Okay, and that's the same answer we got when we just moved the decimal. Okay? All right, so now we're going to do another one-step conversion. All right, so here's my given. What am I looking for? Centimeters. So I'm going to take what I'm given, I'm going to put it over 1, 3.62 inches. Okay, I'm going to extend my line out, draw a line here. Okay, I'm going to get my conversion factors. Well, there it is. It's given to you. 1 inch is equal to 2.54 centimeters. Or I could write 2.54 centimeters is equal to 1 inch. I could write it either way. Either way, it's the same thing. One of these I'm going to use and one I'm not. All right, so what unit do I want to get rid of? I want to get rid of my inches because I want to convert that to centimeters. So I'm going to put it in the bottom, force it to cancel out. Question number 3, what unit do I want to convert it to? Well, I want to convert it to centimeters. So I'm going to look for a conversion factor that contains centimeters in the top, and it's this one. So we're not going to be using this one. So I'm going to put centimeters in the top because that's why I have a conversion factor that has centimeters in the top. All right, so now I'm going to put in my numbers. 2.54 is 1 inch. Cancel out my units. So inch can cancel inch. Am I there yet? Do I have the unit in the top here that I want for my answer? Okay, I want my answer in centimeters. So the answer to that question is yes. So my instruction is to stop and do the math. Okay, so we have centimeters is our unit. We have 3.62 times 2.54. All right, so 3.62 times 2.54. All right, and the number I get is 9.1948. 1 times 1 is 1. All right, how many significant digits do we want? This is the only data that I'm given. Do not count significant digits in conversion factors. Only your measured data, and this is my measured data. Okay, so let me clean this up. We have here 3 significant digits. So our answer can only have 3 significant digits. So my final answer is 9.19 because this 4 doesn't round the 9. 9.19 centimeters is our answer. All right, so we've just converted inches into centimeters. That's a one-step process. All right, so let's talk about multi-step processes. And this one we're going to use units that are familiar with you so you can see more about the setup than you can worry about the conversion factors. So the question is, how many seconds are in 4.35 days? Okay, so how many seconds are in 4.35 days? Well, I'm going to take my give. Well, first let's do our conversion factors. So we need to get from days to seconds. So Do you know of an equivalency where do you know how many seconds are in a day? I don't. But you know what I do know? I know how many seconds are in a minute. So we have 60 seconds is equal to 1 minute. Okay. Do you know how many minutes are in a day? Because we're trying to get to days. No, I don't. But I do know how many minutes are in an hour. So 1 hour is equal to 60 minutes. Okay. Do you know how many hours are in a day? Ooh, that's easy. There's 24 hours in 1 day. Okay. So we've gone from minutes to hours, hours to day. So we can get from seconds to days using these conversion factors. Okay, so let's start with our given 4.35 days, okay, over 1. All right, what unit do I want to get rid of? Well, I want to get rid of days. So where do I put that unit so we can force it to cancel? In the bottom. Okay. All right, so what unit do I want to convert it to? Well, can I go from days to seconds? No, but we can go from days to hours. Okay, so I'm going to put hours in the top here. So put in my numbers, 24 hours is 1 day. Okay, so now we're going to need another conversion factor. So cross out what you can cross out, cancel what you can cancel. So now, am I there yet? Do I have the unit in the top there that I want for my answer? The answer is no, I do not. So we have to add another conversion factor. So when you do that, what you do is you go back up to question number 1 and you just go through these 5 questions again. It's as simple as that. Okay, so question number 1 says, what unit do I want to get rid of? Well, I want to get rid of hours. So where do I put that unit to force it to cancel? I'm going to put it in the bottom. Okay, so question 3, what unit do I want to convert it to? Well, I want to convert it to days, but do I have a conversion factor that goes from hours to days? I don't, but I do have one that goes from hours to minutes. Now, hours is in the top here, so we're going to have to flip it. And that's okay because we can flip conversion factors. So hours in the bottom, so that means minutes is going to go on top. Now, what's the number that you have with minutes? It's 60. So I'm going to put 60 here, and 1 goes with hour, so I'll put hour there. So number 4, cancel what you can cancel. I can cancel hours. All right, so am I there yet? Nope, I'm in minutes and I want seconds. So we're going to add another conversion factor. Go back up to question number 1. What unit do I want to get rid of? Want to get rid of minutes. So where do I put it to force cancel it? In the bottom here. Okay, what do I want to convert it to? I want to convert it to seconds. Do I have a conversion factor where I can go from minutes to seconds? I do. So I'm going to put seconds on top. 60 seconds is equal to 1 minute. Okay, so cancel what you can cancel. I can cancel my minutes because what's on top cancels what's on bottom. Am I there? The answer now is yes. I have the unit in the top there that I want for my answer. So I can stop and do the math. Okay, so you see all of these units have canceled out. I forced them to cancel out except for the unit that I want for my answer. So that is going to go here for my unit. Now, all I have to do is multiply across. So pick up your calculator. I'm going to take 4.35 times 24 times 60 times 60. Okay, and that's, okay, so we're going to have to use scientific notation here. 3.7584 times 10 to the 5th power seconds. Okay, and then 1 times 1 times 1 times 1 is 1. Anything over 1 is itself. So I can stop there. Except for this is not my final answer. Because my final answer can only have how many sig figs? 3 sig figs. So here's 1, 2, 3. There's the number I'm going to look at for rounding. Does an 8 round to 5? It does. So my final answer is 3.76 times 10 to the fifth seconds. And that is how to do dimensional analysis. All right, thanks for watching. Please hit the subscribe button that you see in the lower right there. And please hit the notifications button so that anytime I post a new video, I'm going to start putting these on YouTube. You'll be alerted that the video is on YouTube. But of course, remember, it is on Canvas. Please look in the modules. Well, you already did that because you're watching the video. But for next time, it's always going to be in modules in Canvas. All right. See you in class.